Hey everyone. We're finishing up with section 9.6, which is solving nonlinear systems of equations. To end the last video, we did some solving of systems using substitution. Now we're going to go ahead and we're going to use elimination to help us solve. Okay, so remember, when we did elimination back in like chapter 3, um, we were trying to figure out how to get rid of a variable. So like if we had positive x, we wanted to get like negative x so we could get rid of them, cancel them out. Here it's kind of the same situation. We are trying to get rid of any one of these variables. And if you guys notice, we've got -3, -3, we've got y and y. So actually we're gonna do, this one's gonna work out really, really well for us. What I'm gonna do is I'm gonna start by writing out the original. And then I'm going to take this second equation and I'm going to multiply the whole thing by -1. So this is going to turn into negative y. That's going to be positive 3x, and I'm going to leave a space there because that's not x squared. And then that's positive 8. So now when I go ahead and I add these two equations together, those are going to cancel each other out, and actually those are going to cancel each other out too. So on the left-hand side, that's going to turn into 0, and that's going to be x squared, and then this is going to be positive 6. So right now we're in a really good spot where we can solve using square roots. So let's go ahead, let's get this 6 over on the other side. So now you've got -6 equals x squared, and then remember we want to take the square root of both sides. But here's the issue, this piece right here, we cannot take the square root of a negative number. Okay, if you try it in your calculator, it's not going to work. So for this particular problem, we have no real solutions. And that's just the way it goes. Okay, so your goal, you were supposed to do 4, 5, and 6 yesterday. Now you need to go through and do 7, 8, and 9. Just solving, and actually, honestly, you guys, all of them, well, not all, you won't get solutions for all of them, but at least they have something nice that you can cancel out each time so that you can get rid of one of the variables. If you need to, you can round to the nearest thousandth. Otherwise, if you can leave it as an improper fraction, that should work as well. All right, last example that we're going to do together. It says approximate the solutions of the system to the nearest thousandth. Again, you guys, I'm going to encourage you, just use Desmos. Okay, so I actually already have mine typed into Desmos. So if you want to pull Desmos up, actually, wait a second. I think I only have one of them typed into Desmos now that I think about it. Okay, so I just went ahead, I typed in the top equation into Desmos, that 1/2 x squared plus 3. And Desmos is probably going to be your best bet here, you guys, because you're dealing with some exponentials. Like, if you notice, the second equation is 3 raised to the power x. That's going to be really tough to graph. So if you just want to type that in, I'm going to do 3 raised to the power x. Okay, so here is that 3 to the power x graph. Here is your x squared minus 3 graph. And if you notice, it gives you this intersection point. Okay, so they tell you that the intersection point is going to be 1.194 and 3.713. Then they just ask you in the problem to approximate the solutions to the nearest thousandth, which then exactly would be 1.194 and 3.713. So there's your solution. You might have multiple solutions, so just be aware of that. Then your next task is just to do 10, 11, and 12. Like I said, go ahead, use Desmos. For 10, 11, and 12, you will absolutely get solutions for all 3 of them. If you've got questions, write them down. I will answer them tomorrow. Otherwise, um, yeah, make sure you get the assignment done. Have a great night.